All right, this is the last set of notes for the semester, and I have to warn you, it's a long one. Your poor hand is going to fall right off. The first thing that we're kind of wrapping up here, this is actually from 7.3, and it was just a nice way to wrap up ways to prove that a quadrilateral is a parallelogram. And so we know both sides are going to be parallel. That's what those little arrows mean. Remember, those are parallel, and those are also parallel to each other. Opposite sides are going to be congruent, so these sides and these sides are going to be congruent. Opposite angles we know are also the same, so I can see the opposite angles are marked also as congruent. This is something to be added. This is something that you probably haven't seen before. I think it's from section 3, is that if I have one pair of opposite sides that are congruent and they're both parallel, then I know it's also a parallelogram. So I can see right here, these are marked. These are equal to each other, they're congruent, and these are also parallel. So I can say that this is a parallelogram. And last but not least, we were working on some of these, is that the diagonals bisect each other, meaning that these two now are congruent and those two now are congruent, and we're able to solve algebraically. So the next section deals with parallelograms still, but even more specifically different kinds. So the first kind we look at is a rhombus. And a rhombus is defined as having 4 congruent sides, and it's marked right there. A rectangle is defined as 4 right angles. So I've got 4 right angles. Also, we know still with a parallelogram that these opposite sides are congruent. I also marked that in there, but I suppose I didn't really need to. It's defined as 4 right angles. And last but not least with that part is a square. And we know that a square has 4 right angles and it has 4 congruent sides. In our first theorem here, we're going to talk specifically about a rhombus again and its diagonals. And what we know about a rhombus is that their diagonals are perpendicular. So I can see this little right angle mark in there. So in a rhombus, the diagonals are going to be perpendicular or create a 90-degree angle. Another piece of information we know about a rhombus is that when the diagonals run across, they actually bisect each other. So the angles bisect. So this diagonal runs across and it bisects this angle or splits this guy in half. And it also does the same over here. Since we know opposite angles are congruent, we know all these tiny little pieces then are also congruent. All of those are the same. The same happens on the other opposites, that this diagonal bisects these angles. And so these are congruent and these are congruent as well. Now in a rectangle, specifically a rectangle, there's something about the diagonals that's important to us, and the diagonals actually are all congruent. So from here to here, this diagonal, and from here to here, this diagonal are actually equal. They are the same. They are congruent. And what happens then is that each of these little pieces would also be congruent. In the next section of chapter 7, we deal specifically with trapezoids and kites. So we're still talking quadrilaterals, but these kind of quadrilaterals are important because they just have one pair of parallel sides. Goodness gracious. Okay, so I wrote a couple of examples for you to see that you can see the bases. The bases are where the parallels are running. So you can see these little parallels here where the bases are. And then the other sides are called legs. So kind of similar to a triangle. We talk about a base and we talk about legs. It happens the same in a trapezoid. The other thing that's important to note are these little yellow dots that I made. Those are called base angles. So they're basically the insides of those trapezoids. Much like triangles, isosceles triangles have legs that are congruent. So do isosceles trapezoids. Isosceles trapezoids have 2 legs that are congruent. Isosceles trapezoids also have base angles that are congruent. So I can say that these 2 angles, these base angles here, again, it's made along this base, are congruent. And these green guys up here, those base angles, are also going to be congruent in an isosceles trapezoid. The converse is also true. So if I find that I see 2 angles that are base angles that are congruent, then I could call this an isosceles trapezoid. Another bit of information about isosceles trapezoid is about their diagonals. The diagonals in an isosceles trapezoid are congruent. The next piece about trapezoids are the mid-segments, and this is a big one. This is going to come up quite a bit. And what it tells us is that this mid-segment here, this pink piece, this middle line, is equal to 1/2 the two bases. And I put the bases in green. And then I went ahead and just put some numbers and I assigned it, because sometimes it's easier to see when you can actually look at a number. So what I did was I put 8 for my green base AB, and then I put 12 for my green base DC. And I was able to solve and get my mid-segment because I replaced those in here. So for AB, I said it was 8, and for DC, I said it was 12. 8 plus 12 is 20. 1/2 of 20 is 10. So you can see that you can mathematically, or sometimes algebraically, what we're going to see, solve for your mid-segment. Well, we've taken a look at trapezoids. Now, lastly, the kites. So a kite, specifically about diagonals, the diagonals of a kite are perpendicular. So again, specific to a kite, those diagonals are perpendicular, this guy right here. And just to review too, if you forgot what a kite looks like, a kite has two congruent pieces like this. These two sides are congruent, and then these two sides are congruent. It's a little bit different shape. And lastly, of a kite, the opposite angles are congruent. So these guys right here, this and this, those guys right there are congruent. Last but not least, this little diagram illustrates everything from this chapter. So the whole chapter about quadrilaterals, four-sided shapes, and it breaks down into kind of this family tree. There's parallelograms, there's trapezoids, and then there's kites. And kites, notice, this is it. Kite is kind of a special situation, right? Like no other shape looks like a kite. In a trapezoid, the only other kind of trapezoid we can really break down into is an isosceles trapezoid. That's kind of a specialized trapezoid. Remember that what makes a trapezoid special is has exactly one set of parallel. So a kite has no sets of parallel, and a trapezoid, we have one set of parallel, and in a parallelogram, we have two sets of parallels. And the different kinds of parallelograms that we can break down into is we know we have rectangles and we have rhombus. And then even more specifically, they break down into the most specialized, which is a square.